Hello, hello. How's everyone tonight? We'll see if anyone joins us. If you're hanging out, coming in, join us. Jump in the chat, say hi. Log in. All right, ladies and gentlemen, welcome to Spindle TV. Getting a little bit of a late start tonight, 8:30. So we'll see how well we can get through this. This is not going to be a small project. This is actually going to be a full-size poker table. We're going to design and lay out the parts that we're going to need to build a poker table, gaming table, and we're going to do this in a couple of parts. So tonight we'll focus on the top and everything. We might even jump into SketchUp a little bit and do a little bit of design and everything, but we'll see how far we get. And this is going to be something we're going to be making it in a way that even if you have a small CNC machine, you can make the parts. For the top and everything. So it's pretty straightforward. It'll be an 8-sided picnic table, but we can also, there's a lot of different designs. So, I mean, it can grow into a lot of different things, but we're going to be making a base for it. And again, the base will be done in a way that even if you have a small CNC, you could accomplish it as well. So we'll see what we can do. Brooks, man, take the laptop out, hang out on the patio by the fire for sure. Or just catch us in the next one because there'll be a part 2 to this. All right. So with that being said, we're already getting a late start and everything. Let's jump over to the Vectric software and get the ball rolling, and we'll go from there. So let me share my window, entire window, and let's come over here. All right, now the size I'm going to lay out for the board and everything is going to be for the individual parts of the poker table. We're going to draw the whole thing out in its entirety so you can kind of see what we're going with here. And we're going to see what we can do with making these parts, on the CNC that, where it'll be easy to join together and stuff like that. Let's start off with we're going to do it as a 2-sided job just in case I want to flip it over and carve on the backside. We're going to have a width of, let's go just for right now, 24 inches. We're going to have a height of, it's going to be we're probably going to have to cut it out of a 1x10 simply because the size that the width is going to be when it probably gets all said and done, it's going to be about 7 9/16, and on a 1x8 we're about 7 1/4, so we're a little shy on a 1x8, so we'll probably be a 1x10. So let's just go 9 1/4 here, and then 3/4 inches thick. We will work off of the machine bed for both sides. In my case, I'll work off the machine bed for this one, and we'll start in the bottom left corner. I will be flipping my parts front to back. I like a front to back flip for some reason, if I were going to flip this, and we'll click OK. Now we're going to look at the design, and we'll draw out the design and everything as a whole. Then, with the individual parts and the layout and stuff, it may end up being a thicker piece than the 3/4 inch, one by. It might be an inch and a half thick. It just depends on, what I decide for the, we're going to have the top. We'll have a little bit of a ball nose and then like an apron that goes around underneath. So there's going to be a few stages. Like I said, this isn't going to be all done in one night. We're going to just kind of do this in a little bit of a couple stages, and see what we can knock out. All right, let's take a look at this as a whole, okay? And there's lots of different designs. One of these days, I want to make like a table that's long and narrow for like, Texas Hold'em and things like that. Tonight, it's going to be an octagon, 8-sided table. We're going to go with that route, and then, from there, I mean, all kinds of gaming tables, and it doesn't have to be just for poker. I mean, there's all kinds of, family night board games and cribbage and card games and whatever, right? Uno, right? Whatever you want to do. And so let's take a look at this. We're going to do, I'll draw it out as an octagon so you can kind of see how the sides will lay out, but it's going to be an 8-sided polygon that we'll draw here. And on the sides, we're going to have a side that is 21 3/4. And then the what that's going to do is that'll give me my outside perimeter. So we'll go ahead and create that, and we'll just kind of create it around here. So this will be kind of the outside perimeter. Now, there's going to be an inside perimeter that's going to be same 8-side. The inside, the short edge of each piece is going to be around 15.5. And so if I drop that in there, that kind of gives me the, outside perimeter. Now I'm going to take a polyline tool, and I'm just going to literally connect the diagonals, space bar to finish the line. I'm literally just going to kind of space bar here to here. And then I'm going to take the scissors and trim away all the inside. And really, for right now, I'm going to take this and just kind of move it off to the side so that we can kind of have a general idea of the layout. But I'm really only want one of the parts. So I'm going to just take this and hold down the control key and drag this down. And then I'm going to take my scissors and trim away these two and these two, right? And that gives me this part right here. I don't really need all of these other parts right now. So I can just select them and delete that. And this is going to be the part here that I'm going to, I'll rotate it around. I like the back towards me, so I'm just going to rotate it around. And I'll center it on the material. Okay. And so simple enough, right? As far as creating the, getting the, external shape kind of, laid out. 8-sided polygon, so an octagon. Each side is 21 3/4 on the outside. And then the inside dimension, this inside dimension right here is 15.5. This gives me roughly about 7.54 inches in thickness or width, if you will. Let me go vertical here to get the exact number. Yeah. So let's call it, 7.5625 would be 9/16. It's just between, 7.5 and 7 9/16, right? So we're kind of right there in that, just that middle range and stuff. And so the that is going to be our layout. And what that dictates is we can, again, 21 3/4 and all, we can make 8 of these sides, we're not done with it yet. There's still, you know, we got to put the cup holder in, and, you know, the chip tray area and all that stuff. But the main size of the board, even if you have a small CNC machine, we're only dealing with a 1x10 board, which is 9¼ by 24 inches, let's say, and that gives us some waste and stuff like that. You know, it gives us place for clamps and all that. So literally, we would just be whatever toolpaths that we create for this one piece right here. We can repeat that. Hold on a second. Sunk down real low. You can't see my head there. We can repeat whatever toolpaths we create for this one part. We can create that 8 times, or we can run those toolpaths, you know, 8 times to create the 8 individual parts, and, you know, the assembly and everything. Now, when it comes to the assembly, right, the joining of these parts and everything, someone is at the front door. I'm so sorry. Please forgive me. Give me 1 second. Someone's at my door. Hold on, Beth. It's Hey. Okay. Hey. Yes, sir. All right, man. Thank you so much. God bless our neighbor. He this is why I'm getting so fat. He works at a pizza shop, and every once in a while he treats us to a pizza. Brings us a pizza. How nice of him. All right. So, love thy neighbor. Okay. Before we were interrupted, what I was saying is the ability to make this on a small machine is possible, because we will have the top. As far as the main table itself, it's the main table that these parts are going to kind of get wrapped around. It'll be made out of, you know, probably a plywood. It could be solid wood, whatever you want, but I generally would make it out of plywood, because it's going to get felt covered. We're going to go to Joanne Fabrics or something like that. We'll get a small, thin kind of it's kind of like a let me see if I can pop myself up here for a second. It's kind of like a you know, a real thin, somewhat kind of dense foam, not too thick. This might even be a little bit too thick, but and then there's going to be a nice velvet or felt cushion, if you will, or felt liner and everything. And this just gives some comfort. This just gives some comfort to the playing area, to, you know, and things like that, and stuff, because just some nice cushion and everything like that. So we will there's going to be some different components and parts and stuff, and we'll end up compiling kind of a parts list and all that cool stuff. All right, so now let's talk about really quickly the things that are involved with poker and stuff. So chips, right? So a poker chip, they're different. Some of them are different sizes, some high end, some low end, but the standard is roughly about 3.5 millimeters thick, and about 39 millimeters in diameter, you know, about 1.5 inches, however you want to say it. But for a standard poker chip and all. So what we're going to do is we're going to make some trays that will carve out some little coves and stuff that will, you know, that we can lay our poker chips kind of on the sides. Some people like stacking them up tall. I kind of like them laying on the side, but you can customize it any way you want, right? And what I was talking about before we got interrupted with the doorbell was the joining of the 8 sides and everything. And let me see if I can pull up. Let Let me see if I can pull up. Let me see if I can pull up on Amazon. Let me drag this over. I like these type of furniture bolts and everything on bringing the sides together and everything and all. These now, I just grabbed this randomly, so I don't even know if they're the right size, but they are typically referred to as, what are they called even? Furniture fastener connectors, countertop connectors, table fasteners, whatever you want. They got a bunch of names here, right? Joint miter draw bolts, blah, blah, blah. So this is a 10-piece set, and the, let's see, it looks here that it's 5/16/18 nut. It's 3.5 inches long, and there's a slight 5/16 curved washer, which fits in there, which is wonderful, and it draws together. So the bolt itself is about 3.5 inches long, and it's a 5/16/18 bolt. So yeah, I didn't do too shabby. They have different lengths and things like that, but I think I kind of grabbed right out of the gate. That was luck. But this 10-piece set, and it's not very expensive and everything, and we would have, roughly or typically 2 per side. So let's go back to the Vectric software and let's take a look at this. So we would roughly have, let me switch it around to here. We would typically have 2 of these bolts, and the placement right now, I don't have the placement exact. I'm just kind of giving you that just kind of giving you just a general idea. Give me a second. So we would have 2 of those per side. So there'd be 2, 4, 6, 8, 10, 12, 14, 16 we'd need, of course, on the 8 side, times 2, 16. And also you're looking at about probably, as far as that's concerned, it's $12, for a 10-pack. So, whatever, $20, $20, $30 in the hardware and everything. Now, these parts can also be glued together and everything, but this just kind of adds some mechanical connection as well to just kind of pull things together nicely. There's going to be some wood movement, and if there is, then you can kind of pull things in or adjust if you need and all that stuff. All right, so the for this part, there's going to be a cup holder, right, or a place for kind of a beverage tray area. And let me see here. Let me see if I can pull it up. There are things like this that you can get online. I'll show you another Amazon product. Let's see if I can grab this tab. Where'd the tab go? Oh, there it is. And pull this over here. So there are these insert type cups, these metal cups that come in different, size packages, 5-pack, 15-pack, blah, 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 that kind of thing. You can get them, stainless steel, aluminum. You can get them in different colors and everything. And they're designed where you just can make the hole, and these are just kind of drop-ins, right? And everything. Now, that being said, and all, that's going to play into, if we do have that type of insert, and everything, that's going to play into our overall design. The board that's going to be the main table that these sides are going to go around, and the way that the side that goes around, and the way that the poker trays and stuff like that are. So lots of options and all as far as those types, and they don't always have to be like that. There can be they can be some low profile ones that aren't as deep. There could be they don't have to be as deep or as large or anything. They could be the stainless steel is a nice, it's kind of a clean look, from color fading and all, but they come in different colors, all that jazz, right? So, and you can even get inserts and stuff for the poker table and stuff. We're gonna make our own out of wood and all, but all kinds of cool stuff that you can do, right? And this could be a fun game night table. It could be a serious table. I'll tell you this. In my younger days, when I was doing, just woodworking builds on my other YouTube channel, and had nothing to do with CNC or anything like that, I made a few poker tables and sold them, and they're good money, and they're not hard to make at all, kind of thing. So it could even be that route. It could be just another revenue source or something like that. All right. So on those, let's use the example, one of the examples that I just pulled over as our kind of our guide. And for the purpose of the diameter and size. Now, these are roughly, let me see here, because this is just a random. I didn't have this picked out or anything like that. It's just random product. So give me a second. The cup holder measures about 80 millimeters, 3.5 inches in its outer opening diameter, and then 2 and 17 inches in its outer height, and then 2 and 7/6 inches in its bottom diameter, and then 2.7 inches on its inner diameter. Okay, so the what we need is the outer diameter, and it's going to be the outer opening is what we're going to need. So let me see here. This stainless steel cup holder measures about 80 millimeters inches in its outer opening diameter. It's 2.17 inches tall on its outer height. The bottom diameter is 7, and then the inner opening diameter. Yeah, so 3.15 inches is what we need. That's our whole diameter in our part. And so on our whole, sorry about that. Again, it's just a random product that I grabbed. I didn't have it planned or anything like that. The opening in all 3.15, so it's roughly about what's that, 530 seconds, 730 seconds or something like that. So we'll just go 3.2 in diameter on that. And then we're going to have the coin tray. Now the coin tray area can really be anything, any size and all that that you want. And I'm thinking that 3/4 of an inch is going to be too thin for what I want to do, and also it'll probably beat this up to 1.5 inches thick and everything. But we'll get there when we get there. The coin tray can be just a flat tray, It could have a felt bottom as well. And all the upper edges could be kind of, rounded over and everything. You got a nice little round over and all. It could be an insert. They have tray inserts if you want to do that. Or it could be what I'm planning on doing is making kind of like the little curved cuts for, the chips to sit in. Now, this curved cup for the chips to sit in, it's gonna be we're gonna treat it as a we can use a ball nose bit or we can use an end mill, either one, but a ball nose bit's going to give us a little bit smoother cut. We can do it as if we have a spire or anything like that and we want to make it as a model, we could lay it out as a 3D model, the cuts and all. We can do it as a fluting cut with kind of that smooth ramp at the beginning of the end and all. We could use a bull nose, a wide diameter bull nose bit and everything. And like I said, a poker chip standard size is roughly about 39 millimeters. And to convert that and all, you're just above 1.5 inches, 1.54, 1.53, 1.54 if you're rounding and all that stuff. But so just a little bit bigger in diameter. And then some higher end chips are a little bit larger. They're like 49 inches in diameter and everything. But you're looking at about 3.5 millimeters thick. And that's roughly a little more than 1/8 of an inch and everything. But the number that I care about is that 1.5 inches, right? Imagine if I have a 1.54 inch chip here, and let me make sure y'all are able to see it and we're zoomed in and all that stuff, okay? And I would want to be just slightly larger in my pocket. Not so much as that it's sloppy and all, but just for variation and everything. So on the pocket and everything, I might come in with a 1.5, 625, 1 9/16, pocket area that can sit in. Let's go into node editing. Let's cut the vector here and here. Delete that. And just for kicks and giggles, let's do this. And do this. And then we can move this out of the way. So we would have a tray that's roughly kind of like that. I was off a little bit right there and there. But, we're going to have a tray that, our chips can stack in, laying on their side. They can kind of stack in and everything. They're not too tight to like just, to fit in there and all. And we can go as wide or as deep as we need to, but there's no need to go, there's no need for it to be too tight, and also give yourself a little bit of room and all that stuff. Now, let's say that I was going to stay with this 1 9/16 kind of thing. And let's say that I am making kind of a tray, if you will, that will hold whatever, 4, 5, 6 stacks across kind of thing. And those were sitting in here and they were running across this full length, right? Then you know, just giving yourself that kind of room and that kind of play. Now, I actually like to have a little bit more room, and I'd like to have this over to the side here, and then just kind of have a little flat area. And, you know, I don't even know how far apart I made these. Hold on a second. Let's go horizontal. Some of them are overlapping. Some of them aren't even touching. Let me get that all lined up proper. Watch this. We're going to take this object, hold down the shift key and select that object right there. And we're going to align to the left side of that part. Okay. And when I do that, it's very important that I select the item that I want to align first, and then the item that I want to align to last, the last item, and I want to be on the outside of that item. So I want to kind of like be right on that edge. And let me take a measurement with that and see how far apart I have this. I don't want to go too crazy far apart. But yeah, so just under, you know, 1/4 of an inch, and we'll probably widen it up to make it exactly 1/4. We'll clean it up a little bit, make it exactly 1/4. But once I have this and everything, I can start to just nudge these over. Again, going to the alignment tool, and I'll just kind of touch to the outside. All the while, just making sure that I select what I want to align first, what I want to align to last. And then all I'm doing here is I'm selecting these and hitting U to ungroup and G to group, right? I'm just kind of adding to that group, you know, but I just ungroup them first. That way, as I select them and everything, it just kind of gets everything all lined up, right? And at this point in here, like I said, if it was a model, I could do a 2-rail sweep. I could just, you know, create that model with a curve. We could use a bowl bit, not really a bowl bit, but a bull nose bit to, you know, create that opening. I'm going to try it as a fluting toolpath and see how we get along with that, and see what that does for me. And if not, if it doesn't work the way that I want it to, then we'll do something different. But when these parts get cut out, I'm going to have just a small opening here that is going to be just, I'll get it all to the right size in just a minute, but it's just going to be kind of a flat area. It'll be just milled down. So the chip trays, in this case, there's 1, 2, 3, 4, 5 of them. They'll come across, and they're going to run all the way across. Right now you're looking at a side view here, but they're going to literally run all the way across from front to back here. And then this will just be kind of a flat little area and stuff for miscellaneous stuff. Hell, it could be for a pen, you know, cigar, whatever, you know, who knows? I don't know, but we'll figure it out. All right. So let's take a look at, let me get everything at the right size. I'd like to have my spacing and everything exactly right. The curve itself is fine, but I'd like to have 1/4 of an inch. We're just under, we're at 1.23 inches. But if I'm going to use anything, like let's say if I decide I want to do a round over on these, so it's a nice round edge or anything like that, I want to, you know, just give myself a little bit of room. And if it's going to be a round over, it's going to be a small round over, like a 1/16 of an inch, you know, round over, very micro, just to break those any sharp edges or anything like that. But let me see what I've got here. We have on the right side, we're coming in on this right side here, just under 1/8 of an inch. And it's going to be the same thing on the left side if I measure the left side. And so what's happening is that's why I have, when the two sides are together here, that's why I'm less than that 1/4 and all. So let's kind of get rid of these. Why draw what you can copy kind of thing. I'm going to get one correct, and then I'll work on the rest. So basically, I'm just going to go into node editing, and I'm going to cut the vector here, and I'm going to cut it over here on the right side. And then I'm going to grab this vector and drag and snap it here. I'll grab this one and drag and just one. Give me a second. Got to get rid of this bottom line so they're separate. But I'm going to grab this one on the right side. Move that one there. And one more time. One on the left. Let's get this over into position here. Okay. Now from here, I need to move to the left. It's a negative number. So I'm going to use the move tool. I could also drag and just type in a number as well too, but I'll make a relative move. We're going to go negative 1/8 of an inch. Okay. And on this one here is going to go positive to the right. So we'll go positive 1/8 of an inch. And then we will take these two items, we'll join with a straight line to connect that. And then the same thing here as well, join with a straight line. All right. Now where we joined this at, we ended up creating an extra node. Now, this is silly and stupid. It's not really necessary at all. But each node, each point is a line of G code, right? In things. And, I want to go from point A to B. I don't need point C in the middle here. So I'm just going to come in node editing and delete that point just from point A to B. I want to go from point A to B. I want to make my curve and the same thing like that. So I want to just kind of clean up. I did that. I created that point by, moving the lines and telling it to join and everything. But I want to go back and just clean it up just because. And the bottom area here doesn't need to be closed off or anything like that because I'm using this shape to create my vectors because my vectors have to run straight across for if I'm using the fluting toolpath, the modeling tools, whatever the case may be. So now that I have that shape, now I can bring this over and, connect it to the side here. And then I can hold down my control key and I can drag and snap, to these points and everything. And as long as I'm just kind of cautious with what I'm doing, I should be able to snap right on top. And let's see, 1, 2, 3, 4. Let's go 5. And okay, so I'm going to make a tray. Now, let's take a look just for visual purposes for everybody, right? For visual purposes for everyone, if you're a visual type person, let me octagon poker table and go images And let's look at real quick, you know, online here, right? So many different styles. Well, I mean, they're all similar in style as far as, you know, that, but there's a lot of different styles, a lot of different, you know, bases, a lot of different layouts and things like that, you know, on what, you know, what the trays are, how they are, things like that. Um, you know, this one is divided, yet it is flat. It's not, doesn't have that round edges and all that stuff, right? So there's that division. This one, the chip area, they've kind of got it like for, you know, playing dice games, well, and all, but the chip area is running along the full length, right? And everything, you know, it's one area. I might have different colored chips or something like that. We're going to make a little chip box too to carry all the chips and cards and stuff and all to kind of accompany this. But there's lots of, this one's just all flat, you know, so someone can have their chips stacked high. We'll make a little nice little chip box, you know, carrier for carrying the chips and all everything. But this one, you know, instead of having the people on the flat, it kind of has them on the diagonal. They're kind of in the middle, and, you know, they can, you know, they're sharing the left and the right side. This is for a folding kind of table and all that stuff, but interesting concept, but not one of my, not one that I would find comfortable at all, you know, being on the corner. But it's not really on the corner, let's say, you know, it just has that opening where you can kind of have your elbows, you can, you know, or whatever, you can, you know, have your cards laying there in the middle, and now there's just a nice little flat area. And then your chip areas are on the left and right side, right? You know, and then you have your, you know, beverage compartment is kind of like on the corner. So lots of different designs, lots of different layouts. You can kind of customize however you want, you know, whatever you want and everything. And on the, you know, for me, on the playing area here, this is where the cards are going to be, you know, on this table and everything. That's where the cards are going to play in the play area and everything. And my chips and stuff are going to be close to me, you know, and, you know, all that kind of stuff. And, yeah, it's a big chip, 49 millimeters, not 49 inches, 49 millimeters. Is a decent sized chip, 49 millimeters, not 49 inches. Can Vectric center a component to a bitmap? Can Vectric center a component to a bitmap image? I'm assuming, I mean, it's going to be the perimeter of the bitmap. So when you have an image come in, if you were to import an image and you had a component and you wanted to center the component to the image, yes, right? But it's gonna center it to the image, the perimeter of the image. It's not gonna line anything up or anything like that. But you select the component that you want to select. You select the image last, just like aligning anything, right? But for sure, yeah, no problem. All right, so now on here, let's figure out the tool path for this. Let's get rid of this little circle here. That's the chip. We'll set that over here in case we need to refer to it later. The cup holder, let me see here. All right, I'm going to select this object. I'm going to hit G for group, and I'm going to select this object last. Center that. Select this and this. Center that. Get myself centered there. Okay. Now, when it comes to creating these and everything, this is just my layout down here. this is just kind of the layout. We're looking kind of like at a side view in this instance, but I need to create the vector lines for the inside area of the part. Now, you can literally come in here and create the lines one by one, making sure that your line is straight 90 degrees and just snap, straight in kind of deal. Or if you wanted to, you could use the rectangle tool and make sure that, you're snapped in. And of course, I missed the whole point right there. But then that gives you an extra step. You got to kind of clean away all that stuff and all. So it's just whatever gets you from point A to B, right? Whatever you like to do. This is just a little bit, it's longer, but a little bit easier because I don't have any unnecessary vectors that I've got to delete or anything like that. So just want to make sure, it's very important to make sure that the line is 90 degrees and that when I am clicking, I am snapping to my corner. And it's just kind of rinse and repeat. Now, also, if I draw one line, I don't have to keep drawing lines. I can just hold down the control key and just snap this line to here, hold down the control key, snap it to there, hold down the control key, snap it to there, right? Once I have one line drawn, why draw what you can copy? And it's just as easy to copy, right? Drag and, snap, drag and snap. And you're holding your control key. When I grab any object and I'm holding the control key down, I am dragging a copy of that object, not the original, right? So whatever gets it done. Now, these vectors, if I stop them right here, then that would be silly on my part because they need to come all the way to the end here. Otherwise, I'll have, a part of the, I'll have a part of my box that's, that's doesn't have anything. And I want this curve to go all the way across. So what I want to do, what's very important for me to do is I want to move, let me deselect this box right here. I want to move these out of my way, and I'll just move it down here. I mean, they're just, now at this point, they're just reference. I've already got my lines and everything, right? And now I need to extend my lines, and we have a perfect tool for that called the extend tool, right? So if we use the extend tool, when we hover our mouse over a line, it shows us where that line can shoot to. And if I click where I want it to go to, I can just snap it, extend it. Click here, then click on the line I want to extend it to. Click on the line I want to extend to where I want to extend it to. Click, click, right? So the extend tool just kind of, will help me bring that line. Now, sometimes extending a line does not, in some cases, it doesn't always close the vector if it's meant to be a closed vector. And sometimes it doesn't join them together or anything like that. Extending it just extends that line. Now, if I go look at node editing here, when it extended the line, it didn't create that extra node. There's no extra node there, so it did extend. All it did was push those nodes down, basically, is kind of what it did. And everything, so it just connected them, just straight down to here, and it did exactly what the tool. It extended that line, it stretched it out. It didn't make another line and just add another line to the end of it. It extended the existing line, so there's no extra nodes or anything there that you got to deal with. Okay, so now those are my vectors to create my little cove or my little curve. Okay, so now, if we were doing this as a 2-rail sweep, if it was a model component, right? I'm going to show you the different ways. if we were doing this as a model, kind of a, as a 2-rail sweep, this right here would be our, what's called our cross section, our profile. And that would be what we're, extending to this point and everything. And so the first thing that I would do is the the main vector here. It either needs to be, added or subtracted, right? And things like that. We're building up a shape. So if I was doing this as a model or a component and everything, this whole area right here, let's say I just make it 3/4 of an inch because that's how thick my material is. And I could actually do just the whole thing. Let's select this and just do. All right, now the part that I just created, this first part here, this would be subtracted from there, and it wouldn't be the full 3/4. It would be however deep, I want to go, however deep I want my chip tray to be. Now, this particular chip tray is 3/4 of an inch deep because remember, my chips were 1.5 inches, 1.54 to be exact. My circle that I used to create this shape was 1 9/16, slightly larger, 1.5625. And so half of that 1 9/16, that's what my radius is here, right? And so if I were going to use this full radius, then that would be longer, or that would be thicker, should I say, than my actual 3/4 inch piece if my part was 3/4 of an inch. That plays a major role for me, that tells me exactly that, do I need to go thicker on my material and blah, 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 and all this stuff. Do I want my tabletop to be 1 inch thick and things like that? All of these things, one thing affects another. Long story short, I'm stumbling on my words here, but one thing affects another, and we just got to, play that role. So let's say, for instance, that I bring my part here, this part right here, I make that part a 1 inch thick component. Let's say I'm using a 1 inch material, or I'm milling down to 1 inch, or whatever, 1.5, whatever floats your boat. But I'm just going to go 1 inch. And then my other part here, I'm going to be at that 1 9/16, 5.625, divided by 2, right? Because that's what my radius is. Oh, it would help if I did not hit backspace when I did that. 1.5625 divided by 2 equals, 0.78125. And so that is, how deep that particular area is right there. Okay. Now, this pocket area component and everything does not need to be here because I'm actually going to be sweeping this and subtracting these shapes from there. I just want to kind of show you what that tray area, would look like. So I'm going to turn this off for the moment because we're actually going to come in and create our 2-rail sweep. If this was a model, and on the 2-rail sweep, I am sweeping between these two lines this U shape right here. So I do not need the leg that comes over here or down, right? And so I need to on one of these. I don't have to do them on the all. I just need one. All I need is one. I've got to go into node editing, and I'm going to delete the span right here and here. And that's going to give me this shape right here. So let's select our two lines, our two rails. We're going to go to our two rail sweep tool. That'll be our drive rail selection. This will be our profile. And it is already, believe it or not, it's already drawn as a subtraction. So we would actually leave it as an add component here. We wouldn't subtract. So we would just click apply and let that sweep across to create that area right here. Okay. Now, once I get this all drawn out and everything, we're going to repeat that for these other two rows and all. I can start to kind of really decide if I want a little lip, I want to lower things down a little bit, you know, on this top surface, kind of bring it down a little, just, you know, still keeping my shape and all, but just kind of bringing things down so there's some levels to it. So it looks a little nicer and cleaner and all that, blah, blah, blah. So let's keep this on. Let's keep this going. We're going to start a new component. We're going to select these two vectors. That's going to be our drive rail. This is going to be our shape. And we're going to just apply. Start a new component. Select these two vectors. That's our drive rails. Select our profile. Click apply. Start a new component. Rinse and repeat, ladies and gentlemen. Rinse and repeat. And we could, you know, there's, you know, faster ways that we could probably get it done and all, but hey, it gets it done. So start a new component, and then this will be the last one right here. That's our drive rail. Select that profile. Oops. Select our profile and apply. All right, now we have this general shape. Let me turn off the vectors so it's a little bit cleaner and everything. We have this general shape, but again, it's right across the top. I want levels to this. I want some, you know, this to look, you know, nice and all. So what I'm going to do is I'm going to take my close this tool now. I'm going to take this vector that is the perimeter going all the way around, and I am going to make a flat shape, and I'm just going to make it a thin flat shape. Let's say that I subtract this shape and I make it a thickness of, I don't know, 3/16, 1875. Click apply. Come in here and reduce that down. Okay. Now, in here, this area that I said flat, I want that down lower. It doesn't have to be too deep or anything, but that's this rectangle right here. That is going to be a flat plane. It is going to be a subtract, and I want that. Let's go, just for right now, we'll go a 1/2 inch deep. Okay. And that'll just be a miscellaneous, you know, it'll be kind of a catch-all or something, or whatever the case may be. But that would be our kind of our tray area. And then, you know, just for preview purposes, I wouldn't make this as a model. It would be a profile cutting it out. But just for preview purposes, let's go ahead and take this all the way through. And, you know, it'd be cut out all the way through kind of thing. So that's what our part looks like. Now, that's as a 2-rail shoot. That's as a model. So, you know, we have our, you know, our 3D rough, 3D finish toolpath, you know, cutting that and everything. Let's take it. Let's say that we don't have a spire and all. We can't create it as a model, and we need to do this a different way. Well, we have the molding toolpath, right? So over on the right-hand side, we have 2 toolpaths possibly that we can use for this. Number one is the molding toolpath. That basically is a way of creating molding. This is a molding shape, if you will. And then we also have the fluting toolpath. Now, the fluting toolpath, and also a profile cut with a router bit that has a diameter roughly close to that size, right? You know, a bowl cut and all, but that gets a little tricky on the ends. We don't get that nice flat wall on the ends and everything when we use the bit, because the bit's, you know, round all the way around like a half circle. So it's a little bit messier. So I'm not really going to show you the profile method of that, you know, with using a bit. I'm going to show you the ways of, you know, we're kind of almost creating like a three-dimensional component, if you will, without it specifically being in a spire or anything like that. All right, so let's say that I have to do this as a molding toolpath. Well, with the molding toolpath, it all still applies, okay? The only difference is we're going to have our profile, which is, you know, this shape right here, our profile, and we're going to have one rail. So whatever rail that we're sweeping across. So it would be, typically it's the right rail on the sides, and it just really kind of depends. But on this, our active sheet, the thickness on our material setup, let's go back to a 1-inch thick material, and let's let it regenerate and get rid of that error. If I'm doing this as a molding toolpath, I'm going to use, I'm not going to use one of my small bits. I'm going to try to use, if I have a 1/4-inch ball nose, I'll go with that. It'll be a little bit larger bit, but I definitely want a ball nose because I want that smooth surface. I don't want to, my end mill's got a flat bottom and sharp sides. And on longer flutes, you know, I can sometimes get away with an end mill on longer flutes and everything, but on a short flute like this, it would be more choppy than anything. So we're going to use a ball nose bit, in this case, a 1/4-inch ball nose, and we can use a clearance tool if we need to, because the ball nose is going to ride the full depth of the cut, right? So we can use a clearance tool. And on the clearance tool, I'll use an end mill for the clearance tool. That's my workhorse, 1/4-inch end mill. And the what I need to have is I need to have the drive rail selected. And then I also need to have, hold down the shift key, I need to have my profile selected. Now you see how it's going the wrong direction? So two ways that I can fix this. One, I can just choose the left rail, right? Or I could have this green node here. I could have reversed the direction. Actually, that was the wrong, hold on. Don't want to reverse the direction there. Hold on. I want to reverse the direction on the actual drive rail. Let's try that again. Up here, I can reverse the direction and flip it around the other way. Okay, so either one, whatever floats your boat, whatever gets you from point A to B. We need to be milling between those two lines. Now, the I am creating kind of this curvature here, and that's all well and good, but it's just going to be doing that one at a time, right? Well, what would happen if since I'm doing it as a molding toolpath, and I treated this like a piece of molding, and I kept my connections together here to where, let me join this back from here to here, and from here to here. And I came in with my scissors and now I have a piece of molding, if you will, right? Like think of it like a, you know, dental molding or whatever. Let me close this tool for a minute. I need to join these vectors together as, one open vector here. And in this case, I need to have one rail that this is going to sweep across. And then I also need to decide on which way I want to cut. I want to cut with the grain. It'll kind of give me a bit of a cleaner, it'll give me a bit of a cleaner result, less cleanup and all that stuff. So what I want is on this leg right here and this leg, I don't mind this leg here because this is going to be a pocket. It's going to be milled down, but I don't want my 1/8 inch or my 1/4 inch ball trying to do this little leg. I want it just to kind of come here and stop, and everything without stepping over. So I'm going to stop this by, separating that from that leg. I'll leave the leg there for right now, but I'm not going to separate it. So I want to use this vector here. I want to hold down the shift key. Let's open up the molding toolpath. I want to, once again, it is, bear with me a second. The component I made, that last component I made threw it off. But anyhow, one more time, I want to go into the molding toolpath, and you see how it shoots it all the way across there. So now that shape is going to go all the way across, right? So we'll go ahead and click calculate. Now this is saying, oh, definitely don't want to do that. My leg right here can't have that leg on that end. Hold on, let me take it off because it's the full size of the material. So let me delete that span right there. There we go. All right, one more time, ladies and gentlemen. Let's go in here. Select our vector first. Hold down the shift key. Select our shape second, and then calculate. And we'll have a rough cut that will come in and do the rough area. Was that the rough cut? Hold on a second. Let's try that again. Yeah, we'll have a rough cut that comes in. I was about to say, I knew that wasn't the rough cut. That's going to go in. It'll step it down and it'll step it in as it goes down because it's going to create a curve, right? So the end mill is going to just kind of, get all that out. And then our ball nose bit, our 1/4 inch ball nose bit will go in and, clean that up. Now, we're going to have a little bit of touch up to do right here on the end, just from tool marks and all, a little bit of sanding and everything like that. But for the most part, it is what it is. Let's see here. Couldn't you do it as a molding rail? Yeah. So I think that's what I just did, Timothy. Make sure I'm not seeing your question late and everything. If I'm using the molding toolpath, then I'm going to do the whole thing all at once as a piece of like a molding, right? That kind of thing. And now, if I were going to try this as a fluting toolpath, this would be kind of that, it would be a start of the ramp at the beginning and the end. It would be definitely with a ball nose bit. The ramp would pretty much not be flat. It's going to pretty much be the whole thing. And it would be a smooth cut. And my lines have to go the other way. Bear with me. One. Bear with me. If I was doing this as a fluting toolpath, the lines have to run across, and they have to step over. They have to step over the the full width. So I have a 1/4 inch ball nose bit, and I would want to step over 40% of that, and I would have to draw that line in that manner all the way across. Not that one. Possibly not that one either. But anyhow, select those lines. Let's try that one more time. To calculate that, and then the I don't want that flat in the bottom. I want it running the full length. So it's going to be, instead of 50%, let's go and I got to step over tighter than 40%. Give me a second. I got to step over tighter, 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 tighter. This is why this is not, this wouldn't be, it's options, right? I'm just showing you all the options, but it wouldn't be the most viable option. Let's offset that 0.25 times let's see, 40% was too much, so 0.08. Lord of mercy, Lord of mercy. And again, I'll just do this for right now so you can get the idea. But on the fluting toolpath, you would calculate that, and that way, when it cut, it would create that dish, right? And I only went a short distance, but we got to get that, a little bit of a cleaner cut. We've got to step over that 8%, right? And so there's multiple ways to get from point A to point B. Now, the best way is the molding toolpath in this case. If you don't have Aspire, or don't have the ability to create 3D models, the molding toolpath is the way to go with this one. And with that, that's doing the same thing as if you were making the model. It's creating a 3D model. It's just not making the model, right? It's creating the toolpath, but there's nothing to edit. It's just the toolpath. But it is the best way to go when you're doing something like this. You have 2 bits. Your 1/4 inch end mill is going to be your rough cut. Think of it like a 3D rough cut, if you will. And then your ball nose bit is going to be the finish cut, and it's going to create that finish cut. Now, same thing. Once this is all done and everything here, right? I don't know. Oh, hold on a second. I'm a goofball. I clicked the button that said preview all toolpaths. But now, once this is done, I'm still going to do a pocket cut, taking it down 3/16 of an inch, right? So, because again, levels, I want that level. So here I would come in and I would select my outside rectangle. This would be a pocket cut going 3/16 of an inch deep, 0.1875, with a 1/4 inch end mill. And then I'm going to take that down. I got to clean it up. Hold on a second. I got to go past my edge. Let me get this one done first. This is going to be a pocket cut, a 1/2 inch deep. Ah, 1/4 inch end mill. All right, now you see this step right here. The why you're seeing that is because it didn't finish the other toolpath. But you see these ledges right here. This is where that fluting toolpath finished off right out here. But my pocket cut only finished on the inside. And so I need my bit to cut this cleaner right here. I need it to open up to that edge and all. And so if we were to look at that fluting toolpath in a solid view, you can see where the bit is running to, right? And if I wanted the bit not to run out that far, because that's what the fluting toolpath is, going to do, not the fluting, but the molding toolpath, then I need to shorten up my rails, right? They'd have to be brought in more, but there's no need to do that. I'm just going to take my rectangle here. I'm going to hold down the control key and the shift key because I want to keep it centered. And I'm just going to, come out to the edge. The control key made the copy for me, and the shift key kept me centered. Now I'm just going to hold the shift key, and I'm just going to bring myself right to that edge, and I'm going to run that pocket toolpath again. Not that one. Wrong pocket. This one. And clean that up. Okay. Now on this one, same thing here. I want this pocket right here to come all the way out to there. So I would take this particular rectangle, hold down the shift key, run it right out and just kind of snap it to there. Missed the whole thing by a mile. Hold on a second. And then recalculate that, clean that up. Okay, so all that does is just bring that down that 3/16 of an inch just to give me levels, right? Whatever floats your boat. So that's this part. So now let's do the profile cutout. Okay, let's do the profile cutout. We're going to actually do both of these at the same time. We're going to hold down, or not hold down, we're going to go down the full length of the material. In this case, it's a 1-inch board I'm using. We're going to use a 1/4 inch end mill for the cutting on the outside of the line. Now, just because I'm cutting on the outside of the line, it knows that there's an inside vector selected, so it'll reverse the cut and do the inside cut. I'll cut this part here, preview that visible toolpath. Of course, you can add tabs. I'm not using tabs for visual purposes. This way I can come in here and we can see that part. Now, that's side one. Okay, so yeah, don't forget to save. Let's do that while we're here. Poker table V1. Okay, so now this is just side one and everything, and there's still a little bit more to do because number one, we're going to be flipping this board over to add in our little pocket areas for our bolts, right? That are gonna be there and everything. And also on this back side here, there's going to be kind of an apron coming down, if you think of like a bit of a bullnose. So the there's going to be a rabbit. There's going to be a rabbit along here that's going to that I'll have a probably maybe a 3-inch board, you know, for an apron, if you will, coming all the way around, and then by hand, probably using a palm route or something. When it's all assembled and all that stuff, there'll be a round over done across around the top edge on the outside, rounding and kind of blending everything together and stuff. It's not all can be done on the CNC table. So, but there is, you know, there is 2 sides to this. So let's go ahead and let's go ahead and copy this to the other side. And this one too. That way I know where it's at. And this one, I'll do all 3. So let me get this rectangle right there. So let me copy those also to the other side. That way, when I flip over to the other side, I know where, you know, what I'm working with here. Now, if we go back and look at that hardware that I had picked out, this hardware here and everything, the size that the size of the holes and the spacing and everything that we need, the diameter is 35 millimeters. The greater than 9 millimeters, greater than or equal to, plus or minus, it's trying to give us the diameter of the line of the bolt, roughly around 9 millimeters, a little bit more, just a little bit more. But it's a 5/16/18 bolt that's you know, that's running through there. So for me, the 35, and it's a 5/16 by 3.5 inch bolt. So that's all. That's what I need to know. All right, so let's go back over here. And here's the great thing. So let's say that I was drawing my circle here, and I needed that 35 millimeter diameter, right? And let's say that's the only number I have to work with. You type in the millimeter and you multiply it by the letter I to convert it to inches. Okay, and everything. So you can multiply by the letter I to convert to inches, whatever you need. Now, what this does show me is that everything that I have here, I need to move this over just a little bit slightly, or I need to think about sacrificing a little bit of that flat area or something if I'm going to be, because I'm going to have 2 of these holes for joined together. And as far as their placement, let me do this real quick. And by the way, this angle right here is 22.5 degrees. So if I hold down the control key and I snap it to this end right here, well, that was the shift key, not the control key. Let's try that again. If I grab it here, hold down the control key, I can snap that right there. And if I single click right here on this center part, that gives me my pivot point. And I bring my pivot point over to this corner, then now whatever I, you know, rotate here, I'm pivoting off that corner. Okay. And so the rotation angle at that point, if I go to the rotate tool, it's 22.5 degrees. And the both parts are 22.5 degrees. So that's going to be a total of 45. So I need to, let me just go the full 45. for right now. Okay. Because my other part's staying straight. I'm not turning it. But anyhow, but those angles are 22.5 degrees. Okay. On each side of that. Now, the reason why I'm doing this here is because I need to be able to draw my, let's go, my height is going to be 3.5, and 9 times I equals, okay, I'm going to randomly just kind of rotate that. And this will help me with my positioning. Now, I may not be able to use, and they have different size hardware and all that stuff. I don't have to use hardware. I can face glue or edge glue this together. I can use dominoes. I can use biscuits. But biscuits now, dominoes and biscuits, they provide no structural strengthening or anything. It's just strictly for alignment and all that. They have no mechanical advantage whatsoever. That'll start a debate. But biscuits and dominoes are just for alignment. They don't provide any structural integrity. Okay, looking at this, my bolt is 3.5 inches long, right? That's my bolt. Now my hole, if you look at the graphic and all, and I'm sure they have different lengths. I'm sure they come in different lengths and blah, blah, blah. But the bolt runs just past the center line. Let me try to get this picture enlarged here. Runs just past the center line, right? So just over center to center on there, on those two holes. And if I was going to use that, and these bolts are threaded quite, I mean, they can get cut off. I can cut them down. I can find shorter bolts. I can do whatever the case may be, right? They have, I'm sure in all of Amazon, they probably have different length bolts, depending on what you want. Now, they also have a jig, ladies and gentlemen, that one could use to make the holes in all 4 of those bolts if you're not using a CNC. We are, in fact, using a CNC. So, but they do have jigs for those kind of things. All right. And so imagine, if you will, that I'm just over the center line, probably about like that on that placement. And to get everything in the exact position on both sides, I'm going to use this line right here as my reference. I'm going to just take and draw a line. I'll delete it in a moment. But now I can select this circle, select this line, and tell it to mirror flip about the line. And that's where it goes. I don't know why I'm at a 45-degree angle there, but it is what it is. Let me see what angle that is. That's just 22.5. So, yeah. Give me a minute. Rotate. Now, if I select this circle and this circle, hold down my, or hit group, G for group, Select this line first, select these circles last, and align to the center. That'll put them right where they belong. Okay. I don't need this one. Now I can take that and I can hold down the control key, drag this down wherever I want to, need to put the other one. I'll probably go over, something close to this, what have you. And that tells me that, my part here, I need to I either need to eliminate that flat pocket area, or I need to move everything over a little bit, because this pocket, the depth of it, in the depth of, remember that that pocket on the other side is going a 1/2 inch deep. That only gives me a 1/2 inch on this side. These pockets are a little bit deeper than a 1/2 inch. They're it's a 5/16/18 nut, but it is, hold on, it is, did I close that tab like a goofball? I think I closed the tab. I did. Closed it. Hold on a minute. Browse. Okay, sorry about that. All right, so these washers, or they're not really, they call them washers, but anyway, they are 5/16 inch, curved washers, and that's going to probably be, because it's a 5/16/18 bolt, that's probably going to put them at they're probably a good 3/8 of an inch to a 1/2 inch thick. Regardless, it would bring the cutting the hole, the pocket, and everything for that to sit nice and flush. If you look where it sits, it's just right at flush with the surface. Let me see if I can get it to. It's just kind of flush right at the surface and all. So the hole depth, and there's probably instructions and all that, blah blah blah, for these particular bolts and everything. Whatever the case may be, right? There's different types of bolts and all that. You can pick whatever you want. I saw a negative review there, so we'll probably go back and look at that a little bit deeper and everything. But regardless, this little pocket on the end here is going a 1/2 inch deep. I only have 1 inch, right? So a 1/2 and a 1/2 is 1, and I got to be mindful of that. So I either have to move things over, but I got to remember now there's a cutout here that has a lip on it, right? That stainless steel cup has a lip. So all of these things play a role in what you're doing. And there's not, I'm not saying you have to use this hardware. It's just what I would use, if I was doing this. And for me, I would probably just eliminate, keep everything as it is where I have it. And just eliminate this pocket altogether. So it would look something along the lines of just that, right? And you're not seeing it because over here. All right, drug this out. as long as I could on this one part. But it's definitely detailed. Hour and 34 minutes just on this one piece. Lord of mercy. I need this, not that pocket. I need this pocket right here. Preview the visible toolpath. Not that. Well, I can handle that. That's just 3/16 down. So it's still giving me a little flat area, a little bit of level. I could use it for something, whatever. But yeah, I could stick with that. But I would probably not. I would probably redraw the vector so that this part doesn't get surfaced or pocketed out. Anyhow, the let's flip over to the other side. And on this one, we would have our these two shapes. Let me ungroup this. Ungroup this. All four of those shapes would be welded together. That's a lie. It wouldn't be welded together. They would be aligned like this, but we're going to take and draw. Bear with me a second. And it's very important. Left side of this is the right side of that. So everything's got to line up. You know, I mean, it's literally you got to mirror these parts over. So we'll mirror them over and place this cup holder where it belongs and all that stuff in just a second. But let me draw a line parallel. Stop playing. And weld that together. Okay, so that'll be the two holes there. And then we'll take this and mirror it to the other side. Okay, and that's going to show me that this needs to be slightly moved up just a bit, not much. And so let's copy that to the other side where it belongs. This I'm not worried about because this is actually going to, you know, be that. So this would be my parts here. And now the tool pass would be this. So this is already getting cut all the way through. There's nothing happening right here. So just strictly this and this. On here, we're just going to go the same depth. We're not going to make one shallower than the other or anything like that. We can go just the same depth all the way across, you know, or, you know, for these two things. And we're going to go pocket cut. For this one, I'm actually going to use an 1/8 inch end mill. Actually, that's a lie. I'll use a 1/4. I don't know what I'm thinking. And a 1/2 inch, I would, of course, get the exact, you know, height that I would need for the washer and all, and that's what the tool path would be. Reset this preview. Reset the preview on all sides because I got to recalculate that cutout on the other side. Okay, one more time. So now we will have, let's fix the pocket while I'm here. Let me fix this pocket while I'm here. All right, so preview this toolpath. Okay, flip over to the other side, run this toolpath. This toolpath, by the way, would be cut first before the other side, of course. And so this would be my part, right? So that would be one piece that I would cut 8 times. And again, you can play around with, you know, the chip area and things like that. What you want to do, just, you know, you only have a certain amount of room to work with and things to play with and all. But this would be literally the parts, the part, 8 cuts, and that takes care of the octagon. Now, as far as the actual table, this is the last thing I'm going to say, and then we're going to kind of continue on in a part 2. But let's go back over to side 1 for a second. Here, okay. The the rabbit. Hold on a second. I got the rabbit to do still. Give me a minute. Very important. Very, 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 very important. Bum, ba-dum, bum, bum. And let me really that the rabbit coming into here does not play any role with this. It doesn't affect this bolt where it's going to be or anything like that. So I don't have to like be all, you know, crazy about this, like, you know, oh, I got to be off of it and all that stuff. But I am going to move it down. And to be exact, I'll delete this one and I'll mirror this one. So that I'm like exact. And then I will recalculate this toolpath. Well, it would help if I actually selected all 4 vectors when I did that. Let's do that again. Recalculate. Then this rabbit cut here is going to go probably a good 3/8 deep, 0.4 to 3/8. And don't do that. The bit needs to go off the edge to clean up that edge just a little bit. All right, so what we have at that point is, let's reset this preview on both sides and preview let's get rid of what we don't need. So this one we're going to delete, and that one we're going to delete. So delete those two toolpaths, and then let's preview all sides one last time. And then we're going to pop over really quickly. We're going to pop over really quickly to SketchUp. And I'll show you what the rabbit and what I have in mind and everything for that. Now, let's see here. Why not splines and strap clamp for, you know, yeah, you can do miter splines if you want and all that stuff. For sure. Now, this edge on the front, when this octagon is put together, is going to be a nice round over, small little round over all the way around on the front and the back and everything and all. And so this is what the part is would look like. And this back area right here, there's going to be a lip. So let's take a look at what that would look like really quickly, and then we're going to wrap it up with that. So we're an hour and 45 minutes in. Let's finish this up in just a couple of more minutes. Like when I say a couple, I mean just enough for me to, quick enough for me to draw this part. So we're going to go to SketchUp. All right, so let's take and draw this. We're going to go 21.75 by 7.5444. Let's zoom in here. Let's push pull this 1 inch thick. Let's take a protractor, and from here to here, we're going to go in 22.5 degrees. From here to here, 22.5 degrees. We're going to draw a line from there to there. From here to here. We're going to push pull that 1 inch, 1 inch. We will take from here and come up 3/4 of an inch. Draw a line from here to here. Push pull this 0.375. We're going to take a triple click this, G for group, to make that one. Get rid of the guidelines. Okay. So now let's orbit this around. All right, let's take our pencil here. We're going to draw a line from here to here, to there, and back to there. Push, pull, bring that down. Let's go 3 inches. Let's take first of all, let's triple click that. push, pull. Bear with me just a moment. Stop playing. Bear with me just a minute. Come on now. Trying to hurry. Oh, don't do that. Ah. Don't play with me. One more. Bear with me just a second. Okay. All right. So now let's get out of that. We're going to take this part, hold down the control key, or M for move first, and then hold down the control key. Let's try this again. Okay, sorry. One more time. Move a tool so that I can move the part around, but now I'm going to hold down the control key, so I'm moving this. I'm going to kind of snap it into play here, and I need to rotate this part, and when I rotate, I want to rotate and snap it to here. And then I need to kind of repeat that 2 more times. Q, snap that. Oop. I missed my rotation. Give me just a second. When you select these parts and you're grabbing them and everything, make sure you're grabbing them at a point that, you know, where you can snap to its mate. Q for rotate, and I want to rotate along this line, but I'm not snapped in the right spot. So it's important. Let me flip this up here. Make sure both my parts are selected together. Make sure that I'm snapped there. Now, one more time. When I rotate this, I want to make sure everything, you know, lines up. And now I should be able to take all of these 4 parts, M for move, Q for rotate, dokie, 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 dokie. All right. Now, so on the table, now this is just a rough drawing, okay? This is very rough, very fast, and my roundover is not really a roundover. Right now it's kind of a void. Ignore that, but that's a roundover on the edge and all that wonderful stuff. Now, my sheet of plywood, right, is going to be cut out with these sides. Let's try that again. One more time. I think it went around twice. We'll call that good. You son of a gun. Did I miss a whole line there? Trying to see which line I missed. That one. That's the line I missed right there. Zoom in when you're doing stuff like this, so you get, you know, what you're, you know, when you're and what I'm trying to do is I'm literally trying to, would have been probably quicker and easier. Okay, so that's, I'm off right there, so that's why my line is not drawn proper. Come on, dude. All right. I have gone around this thing more than once. I'm misaligned right there, so that's why things are off. All right, forget it. We're going to do it a different way. Dun, 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 dun. Stop playing. Lord have mercy. Why am I struggling with this? Give me a second, ladies and gentlemen. I'm struggling because I'm misaligned right there on my rotation. Anyway, God almighty, wasting so much time. But the long story short, the plywood is going to get cut out, and it's going to get cut out with these 8 sides. It's going to fit in here. And again, but when this sits down on top and all, it's going to be sitting on that, foam and felt is going to kind of get tucked under and pulled really taut and everything to create a really nice play area and stuff. But we also, have to, when this lays over, we have to line up where our holes get cut out, for our cup holders and all, because they go all the way through. And then underneath that piece, because that piece is going to be sitting down, that, that 1 inch kind of recess minus the cushion thickness and all. And again, we're using, something like this. The long story short is there's going to be a smaller octagon table, and then we go into the base. Now, to show you what we're going to do for the base in the next class, this is the base that I landed on, that I settled on. We're going to cut this out in 3/4 inch pieces. We'll glue them together, sand them and everything to make these legs. And then we're going to do 3 of them. So that's going to be 2 1/4 wide legs. And there's going to be 3. And then we're going to have a center post. And then our base that they get they're going to get notched out and everything underneath the bottom of the table and in the top. So this is going to be the base that we're going to be working with. The design and all, just a 3-legged base. 4 technically if you count the center post. But that's what we're going to be. That's going to be next and everything. So I'll clean up that SketchUp drawing. I'll have everything laid out in SketchUp for the next class. On this part right here, you can see where the rabbit, exposed that, but when the piece goes in, it'll all get glued together. I probably will end up moving that part back a little bit away from that rabbit, just a little bit, shortening that up, and that way I don't have to worry about it. But that is going to get us started, and this is going to be, when it's all said and done, I mean, it's going to be an actual project. I'll have all the plans and everything. Once we get everything like exactly how we want, I'll have all the plans made up. I'll provide them to y'all if y'all ever want to give it a go. But it's going to be a full-size poker table. Going to add some nice, we'll give it some, niceness to it and everything. But I'll resource some of the material for the felt, the links, the poker chips. There's going to be a poker chip box and all that. And yeah, so this is the first step. We need 8 of these. I'll adjust them and all that, but And then we'll need 1 sheet of the plywood. It's all going to be solid wood except for the part that's going to be under the felt and all. That doesn't have to be solid wood. That can be plywood and all. But the base, the wooden base, is going to be a couple of panels that are glued up, and then the 3 legs. And for the smaller tables, you can make one leg at a time, glue them together. Do some finish sanding and trimming and all that stuff. Whatever you want to do, but I mean, this is going to be a full-on build project. You guys can build and all that stuff. And I don't know. I'd love to see if anybody wanted to build a poker table. If anybody built one, I'd love to see it. But these can be things, if you do it well enough. If you do it well enough and everything, my poker tables. They sold for $1,500 a piece. $2,000, $1,500. The cheapest one I sold was $1,500, and I sold a couple of those back when I was building. It was right around the time that I designed my octagon picnic table. Right, I was kind of into octagons back then, but it all stemmed from the poker tables. It was, just a way of making income back then. God, that was 15 years ago now. So anyhow, it's all about increasing Lainey's crown count. There you go. All right, everybody. Well, listen, this is where we're going to leave it off for tonight. We're 2 hours, 6 minutes in. We're gonna stop here. We'll pick up this on the next one. In the next class, we'll have I'll have more full clear drawings for you in SketchUp, so you can see all the different components and everything. And then we'll go in and create the toolpaths and things for them for the layout. But we'll actually have a nice, clean SketchUp drawing. I'll have it because this is off the cuff right now. Just kind of based on what I've done in the past, and also we'll get it all cleaned up, and I'll have the right hardware chosen and all that. And so in the next class, we'll be a little bit more prepared so that this could actually be a viable project and all with all the material lists and all that stuff. All right, everybody. Until next time, we'll see you, and y'all have a wonderful evening. Enjoy your weekend. Be safe, and we'll go from there. Hopefully you picked up something tonight, and then we'll see what we can do with the rest. Not all projects, ladies and gentlemen, are big projects like this. If you're new to Spindle TV, normally we're doing signs or we're just working in the Vectric, making something or another. But, it's been a while since I've actually done a large project, furniture build or anything like that. And I want to tackle another one. So here we go. All right, everybody. Until next time, we'll catch you soon. Thanks.